Welcome, everyone. We are so very excited to have you all join us today for 16 minutes in space. I'm especially excited for tonight's program. We have some amazing people, including Dr. Chun, who I will hand the microphone over to so that he may introduce the rest of the program. Right before I do, sorry, Chun, I did so prematurely. There will be about 15 minutes at the end for questions and answers. Go ahead and type your questions in the chat as they're coming up. I have my handy dandy legal pad down here and I'll keep track. We will try to get to as many questions as we can. Dr. Chun?
Thank you very much, Celine. Hi there, everyone. My name is Chun and I am the Curator of Space Science at the Denver Museum of Nature and Science. And I've been doing 60 Minutes in Space for probably about 15, 16 years now, but I'm really happy to have on my esteemed colleagues tonight. The first up will be Naomi Pequette, who is the Denver Museum's Earth and Space Science Program Specialist. But then we will also have a special guest, Dr. David Grinspoon, who is a senior Venus scientist and astrobiologist at the Planetary Science Institute. And David was at the Denver Museum, but he's now an independent scientist. And I will actually be interviewing him about the recent discovery of phosphine in Venus's atmosphere. And that interview has already been recorded, but David was so gracious enough to say yes to our request for him to be on in our Q&A at the end. So if you have questions about this major discovery, please definitely type them in the chat as Celine suggested. And I think I have one more bit of news before we jump into our presentations. And that is, I want to make a big announcement about the Denver Museum's new Space Odyssey exhibit. Space Odyssey is a go for relaunch. Many of you know Space Odyssey is our permanent space science exhibit at the museum. It opened in 2003, and we actually shut it down earlier this year, back in the spring, for a major renovation. And Space Odyssey is now slated to reopen on Friday, November 13th at 9 a.m. So if you've been missing Space Odyssey, you can look to get tickets online, and there will be definitely be a lot more information about it in coming weeks. But one of the things that drove how Space Odyssey was redesigned is that we actually went out and solicited input from you, the visitor. And so the new Space Odyssey was built around what our visitors wanted to learn about and what they wanted to see. And the whole exhibit has been redesigned around the question of how do we know about what we know in space. And you'll be able to go and visit Space Odyssey and try out kind of old favorites that have been reimagined, like being able to drive a rover on Mars and to see how craters form. But we also have a bunch of new exciting interactives, such as creating your own color versions of space imagery, being able to feel what it's like to be at a rocket launch, to feel what it's like to actually be floating out in the middle of space. I haven't actually tried that yet, but I'm excited to try that out. You can see if you can warp your space-time with your body. And then finally, apparently there's also a hidden disco ball that's somewhere in the exhibit as well. So again, you'll hear more about it in coming weeks in the press and through the museum. So definitely mark this on your calendar. On Friday, November 13th will be the opening or reopening of our new Space Odyssey. And so with that, I just want to give one final bit of background for those of you who are new to 60 Minutes. 60 Minutes is a program that has been running for almost 2 decades at the museum. And what we do is we bring on board our space scientists, astronomers, and educators, and we talk about the most exciting space news from the past month. And normally I talk about astrophysics and things outside the solar system, but that's actually also a favorite of Naomi's as well. And so today she'll actually be focused on things closer to home. And then, of course, later on, we have our special guest, David Grinspoon, talking about the new Venus results. So with that, I am going to turn it over to Naomi. Naomi.
All right. Hi, everyone. Thanks so much for joining us tonight. So as Chun said, my name is Naomi. I am a Earth and Space Science Program Specialist at the museum, and my background is in astrophysics, just like Chun. But tonight I am going to be sticking closer to home. You may have guessed that with our icebreaker question that we're going to be talking a bit about moons. And I've been thinking a lot about the moon this month. We had International Observe the Moon night just last Saturday. And of course, this is a huge focus for NASA with the Artemis program. NASA's next big push is to land humans, and specifically the first woman on the moon, by the year 2024. But that doesn't come without challenges. We've seen some exciting strides in space exploration. I know Dr. Lau and Dr. Lee have talked a lot about the Orion, the SpaceX Crew missions. And of course, we're testing that Orion capsule and the Space Launch System. But we also need to think about being on the moon itself. And there was a story from CU Boulder that caught my eye because of a catchy title. And it's around the idea of lunar dust. Because going back to the moon, we're going to have to solve the lunar dust problem. It was said by Gene Cernan that it's probably one of the biggest challenges to nominal operation on the moon. The dust on the moon really stuck to everything. You can see pictures here of Apollo astronauts in their spacesuits just completely covered by this lunar dust. And they tracked this into the lunar lander with them. And they said they could smell it and taste it in the lander. And that smell ranged anything from spent gunpowder to burnt charcoal to ashes in a fireplace with water on them. But it went beyond just causing an issue of having a dusty house. I have a dusty house, let's be real. It's livable. But the lunar dust is a bit different. So the moon is constantly bathed in radiation from the sun, which gives this material that electric charge, which makes it extra sticky and kind of like static cling here on Earth, opening up a box full of packing peanuts, right? Especially if you have a cat around, they stick to the cat and they end up everywhere. But beyond being this really just sticky material that is attracted to the spacesuits, is dragged into the HAB, it's also jagged and very, very abrasive, kind of like broken shards of glass. And that's because there's no erosion on the moon to grind away its edges, basically. And Apollo 17 astronaut Harrison Schmitt even developed what he described as hay fever because of it. It actually got up in his nose and caused the cartilage plates in his nose to swell. So this is a health risk. We also know that it contains silicon dioxide, which on Earth is associated with lung disease, with stonemasons. So this is something we need to think about, especially for looking at Artemis-style missions that are going to be longer. We want to establish a presence on the moon. We don't want to be tracking this lunar regolith in. So a team up in CU Boulder is creating a lunar dust buster. And this is probably why I clicked on the clickbait as that story came through. And so their idea is to, quote, zap away the grime. And to do this, they're using an electron beam. So an electron beam shoots concentrated and safe amounts of negatively charged low energy particles, electrons. So they set up an experiment with a vacuum chamber, which you can see they're set up there on the right. And they took several different materials that are similar to what they might find in a spacesuit. So things like the outer material of the spacesuit itself, the glass from the helmet, and they covered it in lunar dust simulant. So not using precious resources of samples returned from Apollo, this is material from here on Earth that NASA has determined is very similar in behavior to the lunar dust. And so they put these materials covered in this lunar dust simulant into the vacuum chamber and blasted it with this electron beam. And one of the CU Boulder undergrad students said it literally jumps off. In reality, what that means is it cleaned the surfaces about 75 to 80%, which is pretty darn good. That's a much better percentage than we had before. Now, of course, this isn't the only solution. NASA has been investigating this dust problem for a very long time. They're looking at anything from embedding electrodes into the suit to paint that might dispel electrical charge. But the team up at CU is arguing that this would be a cheaper and easier to implement solution than what has been tested before. And the idea is that astronauts in their spacesuits covered in this dust could walk into a shower of electron beams. So obviously this is a pretty small scale experiment. There's lots more work to do. They're working on scaling up and increasing the strength of their electron beam, but a really exciting next step and something that's going to be critical to us getting back to the moon, potentially as soon as 40 years from now. So another thing we're going to need for the moon is the dust. Is not just the dust that we have to deal with, right? But we need the spacesuits themselves. And we know that the Apollo spacesuits had challenges. You can see astronauts there in the video doing that kind of classic hop movement. And of course, we have developed new spacesuits since Apollo. The spacesuits we use today on the International Space Station were designed for the shuttle program and designed not to work on a lunar surface or on the Earth, but in that microgravity environment of space. But both of these suits face challenges of mobility. We know that the Apollo astronauts really struggled with mobility around their knees and their ankles and being able to walk. And so they developed this bunny hop, which made mission control extremely nervous. They were really worried about them falling, jumping like this. And as I said, the spacesuits that we have today have had a lot of issues in and of themselves. They are considerably up there in age, and they just don't have the mobility we would need to be on the surface of the moon. So about a month or so ago, NASA introduced a brand new spacesuit called the Exploration Extravehicular Mobility Unit, or the XEMU for short. You can see it's gotten a colorful upgrade, but it's gotten a lot of functional upgrades as well. And really the focus was on the science and the field tests that are going to need to be done on a lunar mission. And so they wanted to create a suit that allowed for that movement and handle that really dynamic nature of those experiments that we think astronauts will be doing on the surface. So as I mentioned, those Apollo astronauts did the bunny hop. So one of the first things they did is look at more flexible materials to allow for more mobility in those leg joints. And so we should actually be able to walk on the surface of the moon now. And astronauts wearing the XEMU suit will actually be able to do something that seems really mundane here on Earth, but is pretty incredible. They're going to be able to raise their arms above their heads. You can see one of the spacesuit engineers there wearing a test XEMU, actually giving a high five, which is huge. That takes a lot of different joints to be able to do that. So let's take a quick look. NASA's released a video so you can see this suit and their other suit in action. So wow, there's a lot in that video of really, it seems like subtle but pretty incredible feats. So one of the things to notice is how many more joints there are in this spacesuit. You can see that this shoulder there is not a continuous piece that allows for some of that movement up and around in that shoulder joint that she was able to do. And what's really even more incredible is that this amount of mobility is able to be achieved at higher pressures than we currently pressurize our spacesuits. So pressurizing spacesuits actually makes it more difficult to move because you're fighting against, in the case of the ISS, the vacuum of space. One of our partners, astronaut Kjell Lindgren, has actually described that trying to move the hands as really trying to really grip something as being extremely difficult because you're fighting against all of that air in your spacesuit and the vacuum outside. So being able to do things like bend on the ground, move at the waist is huge. They also are taking a note from Russian spacesuit playbook and actually designing it to be entered from the back. So if you ever watch videos from the ISS today, as they get suited up, they kind of put on the torso, put on the pants and attach those. You saw our spacesuit engineer here crawling in through the back. Although of course, for emergency purposes, there's multiple ways to get in and out of the suit. But beyond that mobility, there's also some other tech changes. If you watch any Apollo footage or if you watch Apollo 13, you'll see them putting on that infamous Snoopy cap, that black and white cap that has their microphone in it. That was notoriously uncomfortable. And so they've actually built in the comm systems into the suit itself. And they've really thought about size. If those of you that were around about a year or so ago, I gave a presentation on the fact that we have trouble with spacesuits and sizing, and that led to the cancellation of the first all-female spacewalk. And so they have made this suit more modular, so it really can accommodate any size astronaut and have a lot of flexibility to be able to respond to these missions where we are further away, and we want all of the astronauts to be able to go out on an EVA if necessary. And of course, we can't forget that pesky dust that we talked about, right? Dust can get into everything, so they've really thought about how to protect this suit. So there are fewer seams, there's no zippers, no cables, and there are seals to protect all of those bearings like we see around the waist there in that image, to make sure that we don't get any dust or grit in there that would prevent that mobility. But we've got to have a suit too to get to the moon. This is the Orion suit, or the suit designed to be worn inside of Orion, excuse me, and it's really designed to keep astronauts safe as they get into space and as they come back from re-entry. So this launch and re-entry suit may look a little familiar. The shuttle suits, of course, of the same style were orange, and that's actually a safety feature in case there ever needs to be an emergency egress in the sea. We want to be able to see those astronauts really, really well. But they have done some improvements, of course. The helmet is lighter weight and stronger, and if you've noticed and watching the SpaceX Crew Dragon launch, there's a lot of touch screens in space capsules today, and so they do have capacitive touch gloves. And the suit itself has its own life support system. It is completely independent from the capsule itself, which is really exciting. It can remain pressurized at 8 psi for several days and almost a week at 4.3 pounds per square inch, or PSI. So it has a lot of new life support functions and is really equivalent almost to that XEMU in terms of that's life support. Now, there's still further design refinements to happen and a bit more testing to be done. Of course, it's gone through extensive testing already, but the XEMU should get a tryout on the International Space Station, they say in the early 2020s, so hopefully in the next year or two, which will really set the stage for being able to send astronauts to the moon. Now, there's a lot of moon stories out this month, not just about our moon, but about Jupiter's moons as well. There was a new study that was released that suggested Jupiter's moon count, already a hefty 79, could be as high as 600. 600 moons, that's really crazy. So they use some modern digital astronomical tools, and overall, we've seen this huge improvement in imaging technology that we can see fainter and smaller objects. And this team really utilized some modern techniques and modern cameras. So they used the Canada-France-Hawaii telescope on Mauna Kea, and they took existing images of a very small area of sky, about 1 square degree. And they analyzed looking for small moons around Jupiter, and they found 52 objects, which is really pretty incredible for that small an area. Now, the brightest of these, 7 of them, were already known, what we call irregular moons or small moons. The moons you're seeing in this image composite here from NASA are the largest moons. These are the Galilean moons. I know some of you said you loved Io, that's there on the left, Europa, Ganymede, and Callisto. So these are much, much smaller. And they took what little sample they had and extrapolated that out to the area around Jupiter and said there could be as many as 600 of these moons around this behemoth planet. Okay, so what does irregular versus regular moon mean? So regular moons we think of as spherical. They are larger, much like those Galilean moons, like our moon. They formed by accretion of material probably around the disk of the planet. So forming with the planet or shortly thereafter, like our moon, and formed similar in mechanism to the way the planet's formed. These irregular moons, these smaller moons, like we have of the image there on the left, are likely captured objects. Jupiter, it has a ton of gravity and it is close to that asteroid belt. So if things get too close to it, it could get captured in orbit around Jupiter. Earth does this too. Occasionally we have another small irregular moon that isn't visible in the night sky to the naked eye like our moon, but we do that as a planet as well. So here's that beautiful telescope, the Canada-France-Hawaii telescope. They used a camera on there called the MegaCam, which is a 340 megapixel wide field imager. It's a really incredible piece of instrumentation. And there were 60 pictures or exposures that were about 140 seconds long each of this region near Jupiter. And what they did to be able to pull out these small, faint objects was to do something called shift and stack. So stacking is adding images together, just layering them. And shifting, of course, is what it sounds like, is moving them in position. And what they're trying to do is mimic potential orbits of these small objects and really highlight very small, faint objects that might be moving relative to background stars and references. So this was a matter of combining these images 126 different ways. It was really quite a feat. And as I mentioned, from that they found 52 objects. 7 of them were already known. And of those, 45 are likely what we call retrograde moons, or moons that orbit in the opposite direction from Jupiter's rotation. And they took this small area and extrapolated it out to get 600 moons. Now, of course, this isn't firm. We don't know for a fact that all of these 600 exist. This would need to be confirmed by observation. But these objects being so small and far enough away from the sun that they aren't going to reflect a lot of light, which makes them very, very hard for us to image. And this would be a huge search. It would just take a lot of time to image all of them. So the authors do point out that this might not be scientifically worthwhile to pursue confirming all of these moons, but still an interesting thought out there. As we continue to observe, we continue to get new technology, we find new objects and new discoveries in our solar system, which is what I found so exciting about this. But it also brings up the idea of what is a moon? Is there some object that is too small to be considered a moon? So some of the natural satellites we see out there that are small get referred to as moonlets, but that's a pretty unofficial term. And the International Astronomical Union, who is in charge of naming everything in the universe, at least according to us Earthlings, won't actually give an object that's smaller than a kilometer, or about 0.6 miles, an official recognizable name like Ganymede or Callisto. So is that the cutoff? What do we call these smaller objects? What are they? We don't really know. This is a debate for the International Astronomical Union at some point in the future. But the fact of the matter is it doesn't change that they are very interesting objects to look at. They have cool histories to them, and they are keys to helping us understand our solar system. So whether we call them moons, moonlets, or something else is not really relevant, but something we might want to think about in the future. Okay, so one of the things I wanted to end with, because so many of the objects we're talking about tonight are actually visible in the night sky. So I wanted to look a little bit about what's up in the night sky. This is how I first engaged in astronomy and really got my passion for astronomy going, and it's something I've done a lot of during quarantine, quite honestly. I also found a pretty cool new tool from Time and Date that does a lot of things that we do in our planetarium. So I'm going to go ahead and do this little bit of a clunky stop share and reshare of my screen here so you all can see what is going on. There we go. So you can see this is set to about 9 o'clock tonight. We're looking out to the southeast. There's that big, beautiful moon. It's going to be a full moon tomorrow, but still go out and look at it today. It's had some really interesting colors as it's been rising because of all the smoke in the atmosphere. But we also have Mars up and Jupiter and Saturn up as well in the south. But what's cool about this tool is it allows you really to look around in the night sky and see what you can see from each and every direction. You can click on objects and find out more about them. But one of the big discoveries, of course, this month, which Dr. Grinspoon and Chun are going to talk about here in a bit, is, of course, the Venus discovery. So if we flip over to this morning, this is what I get for driving live. There we go. And we switch to AM, there we go, and we look out to the north. Apologies. We should see Venus. Where are you? I apologize, but Venus is up right close to Leo. As I search around, there we go. Sorry, out to the east. There is Venus big and bright as a morning star. So this is from a website called Time and Date. So I highly recommend you check it out. This was tools that were a little expensive, sometimes hard to get when I first started out in astronomy. So really powerful, cool tools to be able to see what's in the night sky from your location. And with that, I'm going to turn it over to Chun. And Chun, you are muted. I apologize.
Thank you. Thank you very much, Naomi. All right, so as many of you might have heard, just a few weeks ago, there was a big announcement in the news about the discovery of the gas phosphine, or the molecule phosphine, in the atmosphere of Venus. And the reason why that became really exciting for a lot of people is that one of the ways that phosphine is created on Earth is through life. And so this raised the possibility of life on Venus. And to answer whether this observation and this discovery actually points to the discovery of real life on Venus, I'm going to now switch over to an interview with David Grinspoon that we had recorded earlier. And so I'll start sharing that. But remember, you'll have a chance to ask David your questions about this discovery. So please enter them into the chat if you have one. I am with David Grinspoon, a planetary and astrobiology scientist at the Planetary Science Institute, who is based in Washington, D.C. He is an expert on Venus and terrestrial planets and their habitability. For those of you in Denver, you may remember that David was the curator of astrobiology at the Denver Museum of Nature and Science before he moved to D.C. His latest book is Chasing New Horizons, about the Pluto mission with Alan Stern. But his very first book was actually Venus Revealed, which he wrote more than 20 years ago. So welcome, David.
Thanks, Chun. It's great to be here as much as we're anywhere, and hello all my Denver people. It's great to see you, at least virtually like this.
So let's get this out of the way first. There was no discovery of life, despite what a lot of the headlines and a lot of news anchors have been saying. So what is the discovery? Why is the molecule phosphine so important? And why did Jane Greaves, the lead scientist on this discovery, look for it on Venus? Why is all this important?
Yeah, so right, we haven't found life on Venus, but we have found something strange on Venus that could conceivably be what we call a biosignature, a sign of life. You know, it's probably not, but there is a genuine mystery there, which you know, could legitimately be a biosignature, and that's what's exciting. Even if it's not a biosignature, it's something we have to try to understand. Now, I say, you know, could be a mystery, because it's also possible that the observation, there's a problem with the observation, and it's not really phosphine on Venus. And the team that did this observation, they, they're a reputable team, and they reported that they believed they had found phosphine on Venus, but it's a very difficult kind of observation to make. They did this with radio telescopes in the sub-millimeter range, and they found one line, spectral line, something being absorbed in the atmosphere of Venus, which they identified as probably phosphine. But you can be sure a lot of people are going to be trying to repeat this observation and critiquing it, which is normal and good in science. When somebody makes an extraordinary claim, you can bet that other people are going to be trying to knock it down or find another explanation. And so we'll see if this phosphine report holds up. There's a lot of skepticism, and so I don't know about that. But in the next year or so, there'll be people repeating, and we'll know if it's phosphine. We'll confirm that. So let's assume it is phosphine. That's exciting because phosphine is actually a gas which, prior to this discovery or this report, was already identified as a possible biosignature that you could find in another atmosphere. And there's a lot of attention to these biosignature gases and atmospheres, mostly because of the exoplanets, because we know about all these planets now around other stars that we have no way of visiting, and we can only observe, hopefully, with spectrometers, the gases in their atmospheres. So there's a lot of attention to what gases could we find that might be a sign of life. And one of these had already been identified, phosphine had been identified as a promising biosignature gas that if we saw it on an exoplanet, a rocky exoplanet, I mean, you find it in planets like Jupiter, and that's a different story because they're all hydrogen rich, and phosphine is a gas of phosphorus and hydrogen, but you don't expect it on a rocky planet with a carbon dioxide atmosphere like Venus. So it had already been identified as a gas that if you saw it on a rocky planet, you'd say, wait a minute, that could be a biosignature. And now it's been reported on Venus. So of course we're like, this is pretty interesting.
What causes phosphine on Earth? We talk about it as a biosignature, and by that we mean it's an indicator for life in the atmosphere of our planet that we are observing remotely. So what makes phosphine so special? On
Earth, the phosphine in the atmosphere pretty much all comes from life. It comes from, in kind of odd places like decaying fish and penguin poop and, certain bacterial species make it in anoxic environments, that is environments that don't have any oxygen. But it's all from life, or on Earth from industrial processes. And that's kind of weird too. Like one of the sources in urban areas is meth labs. Well, nobody's proposing meth labs on Venus. And so it's something that is not easy. It's not just that it mostly comes from life in Earth's atmosphere, but we don't know of ways to make it very easily from non-biological processes. It doesn't there's a little bit of it in volcanoes, but supposedly not nearly enough by orders of magnitude to make the phosphine we see on Venus, even if there were a lot of volcanoes. So how to make it non-biologically is not clear. That doesn't mean there isn't a way, but we don't know of a way.
And you mentioned earlier that this result will be, I don't want to say ripped apart, but it's a natural part of science for competing scientists who are not part of the team to start nitpicking it, to start looking for cracks in their arguments, and to make their own observations. So what exactly about these observations, about how they're taken, or perhaps it has something to do with Venus itself and how difficult it is to observe, that should make us more skeptical about the headlines that we've seen?
A few things. In a general sense, there's the saying that that Carl Sagan is famous for, and I think actually goes back further to some, classical philosophers, but basically that extraordinary claims require extraordinary evidence. So you can be sure if there's a sensational finding, like we found this gas that doesn't belong on Venus that may be a biosignature, that appropriately a lot of scientists will be skeptical and try to find other explanations for what's been found. That's just, the way science works. And anything that anybody publishes is fair game for another scientist to try to find a problem with. That's how science keeps itself honest, but especially something that's, really extraordinary like this. But in particular, I'm not an expert at sub-millimeter observational astronomy, but apparently there were some aspects to the technique that was used for this that were kind of on the edge, like it was a marginal detection and there were other possible explanations. So, I mean, I don't have any reason to doubt, I know that the team that did this has a good reputation and has done a lot of solid work, and they clearly did their homework as far as looking for obvious errors. But I know there's a lot of people in the astronomy community saying, wait a minute, we really got to check this and make sure it's legit. So on the observational side, it's just it's a difficult observation to make, and like I said, they only had one spectral line. Sometimes you see a whole bunch of spectral lines and you can really find a fingerprint. This wasn't that. This was one line, and they said, well, we don't know what that is, but at least phosphine fits, and so it's a little more marginal. So there's that, and then there's the question of, is there really no other way to explain it in the atmosphere other than life? And there's a lot about the chemistry of the atmosphere of Venus that we don't understand, and this is a positive thing, because if nothing else, it'll spur a lot more research and investigation, both in terms of laboratory investigations on Earth, people saying, well, let's simulate that environment. Let's put phosphine in a Venus-like environment and see what it does, or see what other chemicals we would predict that should be there that we could observe. And then there's the interesting question of, well, should we go to Venus and check this out? And that's, personally, I'm excited about that, because I want more missions to Venus, and I've wanted that long before this was a new report. But if this helps the momentum for new missions to Venus, then that, in my mind, that's a plus.
Let's talk about that in just a few minutes. Earlier, you mentioned Carl Sagan and his line about extraordinary claims needing extraordinary evidence. Sagan actually wrote a paper back in the late 1960s bringing up the topic of life on Venus. And in your book, Venus Revealed, you also talk about that as well. So when we think of life, elsewhere in the solar system, we usually think of Mars or Europa, and we usually don't consider Venus, which we don't think of as being habitable. But obviously people like you and Sagan have thought about it. So how does this previous thinking fit with the possible phosphine discovery today?
Yeah, so I mean, Venus is a planet that as soon as we started to learn what it was actually like in the early part of the space age, the first ever mission to another planet that succeeded in sending back data was Mariner 2 to Venus in 1962. And what it showed us was that Venus is uninhabitable, at least the way we normally think of it. And we've confirmed that with later missions. It's so hot and so dry and so high pressure, and the atmosphere is so caustic that it's almost the last place you would think of looking for life on the surface. And we usually think of life as something that exists on the surface. But Sagan and Carl Sagan and Harold Morowitz pointed out in their paper, I guess in 1967, that was published in Nature, well, actually there's a zone up in the clouds that is moderate in temperature and may have the other requirements for life. So they put this out there that there could be a habitable region of Venus up in the atmosphere. And, I think that was, people said, that's interesting, but nobody really did anything with it. And that time, exobiology was more of a fringe field than astrobiology is now, because of what we've learned so much about extremophile organisms and about exoplanets. And, there's all kinds of reasons why astrobiology has become more acceptable to think about finding life elsewhere since then. But the other thing was, I wrote my book, Venus Revealed, in 1997, right after we had gotten the Magellan results from Venus, where we really first saw what the surface of Venus is like. And what we learned was that Venus is a pretty active planet geologically, that it seems to have a lot of volcanoes probably still active, and that it's had a history of a lot of, there's not a dead world on the surface. And that got me thinking about this idea, not just because the clouds are temperate, but because there are these flows of, there's interesting chemistry, that the volcanoes are feeding chemistry in the clouds, and there are these sort of chemical cycles, just like the chemical cycles of Earth, that help make Earth such a good place for life, the carbon cycle and all these cycles that life sort of feeds off of. And I saw that there was something analogous on Venus, that it was a fresh, active planet with a lot of chemical flows. And that got me thinking that not only are the clouds temperate, but potentially there's a lot of sort of chemical activity that life could potentially ride on. So I put out this idea again in my book, Venus Revealed. And again, I think, people responded maybe politely, but skeptically, as they should. And there were a lot of eye rolling because I gave a lot of talks at conferences. I'd be the guy giving that talk about life in the clouds of Venus. And people would be like, well, that's interesting, but didn't get taken too seriously. In recent years, though, it's interesting. There's been a little bit of a revival, not just from me, but other scientists have been writing papers and looking at this possibility of life in the clouds of Venus starting really a few years ago. So the timing is interesting of this report because I think there was a little more receptivity. And, phosphine, if it does turn out to be real, is something that you have to explain away. And there very well could be some less exotic explanation than life, but it is interesting that, some of us have been focusing on this possibility of life in the clouds. And then now here's this, if it's real, this potential biosignature that either is evidence of some chemistry that we didn't understand, which would be an important thing to learn about anyways, or, who knows? I don't give it a very high percentage of being a sign of life on Venus, but I don't completely rule it out. So I find that exciting that it just kind of reopens the question a little bit.
I'd like to talk a little bit more about some of that recent research. I think we've long known that Venus, Earth, and Mars had very similar conditions early on. And I think a lot of people took it for granted that Venus dried up and got really hot very early on as well. So if life got started on Venus, it probably didn't last very long. But what is the current thinking about how Venus has evolved over the history of the solar system?
Yeah, that's another interesting part of this whole picture of sort of changing ideas about Venus, because like you said, we've thought for a long time that maybe very early on, Venus was pretty Earth-like. We see some evidence that it used to have a lot more water, although we need to verify that with new missions that would get us better data. But the data we do have suggests Venus probably lost a lot of water, and it probably formed with more water, more similar to Earth. And then there's this idea of the runaway greenhouse, that it probably lost its water through a feedback between the fact that water vapor absorbs infrared radiation, so it is itself a greenhouse gas. You heat up the surface a little bit, water evaporates, it makes more greenhouse gas, that heats up the surface more, and before you know it, it runs away and you lose your ocean. So that's sort of the common idea we've had about Venus, and we used to mostly think that happened really early on when Venus was a young planet. But more recently, people have done more sophisticated climate modeling of Venus. And they've used these GCMs, the general circulation models, which are the same tools we use to predict future climate change on Earth. And we finally gotten to the point where we can really apply them pretty well to the the climate history of Venus. And what we learn is that it seems more likely that Venus kept its oceans for longer, that when you include the dynamics of the atmosphere, the motions of the atmosphere and the clouds and the way the clouds reflect sunlight and sort of move around the planet, that it becomes easier that in fact the models point towards a much longer oceanic phase on Venus. So there's still a lot we need to understand, but it's looking more credible that Venus had oceans for most of its history, maybe until just 1 billion years ago, which is a really interesting picture. Then you have these two planets right next door, Venus and Earth, that both maybe had surface oceans and maybe even evolving biospheres all that time. If Venus was just like Earth all that time, then why wouldn't it have had life and maybe even sophisticated life? Because after billions of years, life on Earth, did some pretty interesting things in terms of evolution. Maybe Venus did similar things. We don't know. But then the question is, of course, well, what happened to that life when Venus went bad on the surface? Because clearly it's not like that today. And one possible answer is that it migrated up to this seemingly habitable niche up in the clouds. So, this is all conjecture, but with astrobiology, that's sort of the name of the game because we haven't found life elsewhere. Just as we sort of have the conjecture, well, maybe when Mars dried out, life retreated to the subsurface. It's reasonable. We haven't found it there yet, but I think it's sort of just as reasonable to say, well, maybe on Venus, when the surface died out, life retreated up into the clouds. To me, it's sort of that same level of a plausible story that would need to be confirmed before we really believed it.
Those are just amazing ideas to think about. You mentioned spacecraft missions earlier. Maybe we can end on this. It's been about 30 years since the United States sent and launched Magellan, its Venus orbiter mission. And currently we do have other spacecraft in orbit that have been sent by other countries. So is there hope that we can learn more about phosphine and other biosignatures from the current missions? And if not, what are the possibilities with future missions that are on the drawing boards right now?
Yeah, I mean, we need more missions to Venus. There's been a drought, and like you said, it's been a very long time since the United States sent anything to Venus. We have had the European Space Agency orbiter Venus Express and a Japanese orbiter Atsuki is there now, but it's been a long time since we've sent anything into the atmosphere of Venus, and clearly that's how you would check out a result like this. I mean, the United States hasn't launched anything to enter into the atmosphere of Venus since 1978, and nobody has since the 1980s when the Russians last did it. So it's been a long time, and we've never had 21st century scientific instruments sent to the clouds and atmosphere of Venus. So we need to do it, and that's been apparent long before this discovery, but this maybe adds a little more push to that. There are 2 Venus missions that are now in what we call Phase A, which is like the finals of the consideration for the next NASA planetary mission, the next what we call Discovery class missions. There are 4 missions that have made it to the final round, and 2 of them are Venus missions. One's an entry probe called Da Vinci, and one is an orbiter called Veritas. They're both great missions. I have to say I'm on the team of Da Vinci, so I'm not a neutral narrator here, but if we want to understand this mystery of the chemistry of the atmosphere and the clouds, let's send something into the atmosphere. So that's, NASA's going to pick 1 or 2 of those missions early next year. In fact, maybe they will pick both Venus missions. They could, which I think would be cool because they're complementary missions. It's not like they'd be redundant. So that's the next step, is hopefully 1 or both of these Venus missions will get selected by NASA. There are other possible missions on the books. The Russians are talking about this Venera D mission, which is a very ambitious mission, which has balloons and entry probes and all this stuff. I'm not sure how realistic that is anytime soon. There's also a European Space Agency mission, which I think isn't until like the 2030s, but is also a very ambitious multiple platform mission. The Indian Space Agency is talking about maybe doing a balloon mission. So there's sort of global set of possibilities. There are also private organizations, and this is very interesting and new, talking about Venus missions now. There's the Breakthrough Foundation, which does, they fund Breakthrough Starshot and Breakthrough Listen, these innovative ideas about interstellar missions, and SETI. They're actually talking now about possibly funding a Venus mission to look for life, and they have funded a study. And I'm part of that study where they're at least giving us some seed money to develop a concept for a possible, it would be much smaller than the NASA missions, but because it's private, we could be less risk averse and do some kind of innovative new technology. And there's another company, a company called Rocket Labs, which is talking about sending a small privately funded mission to Venus to check this out. So this is an entirely new thing, the idea of privately funded interplanetary missions to look for life. And this is something that's, really just in the last couple of weeks since this phosphine announcement, these organizations have been saying, hey, we're interested in sending a Venus mission, and not even government organizations. So it's a whole new ball game. And I don't see them at all as competing with NASA or with these other, or it's just, the more the merrier, and probably they would end up partnering in some ways. So one way or another, I think there are going to be new missions to Venus. And, whether or not the phosphine mystery persists, there's a lot of compelling reasons to go to Venus to study the climate and the evolution and indeed the possibility of life there.
That is absolutely amazing. I hadn't heard about these private attempts at all. It's unbelievable, but it makes sense given that there's so much private funding that is going into space exploration. Well, David, I thank you very much for dropping science on both past Venus as well as future Venus discoveries. And I hope you can join us again in a future 60 Minutes in Space episode.
Well, thanks a lot, Chun. Great to see you. And to all my Denver friends, live long and prosper.
All right. Take care. Stay safe. Bye-bye.
All right, thanks. Bye-bye.
All right. I want to thank David again for that interview, but we can also ask David questions along with Naomi and perhaps even myself. So I want to turn it over to you, Celine, for our Q&A.
Thank you so much. I learned so much about Venus, I have to say, in terms of my space knowledge gaps. There are a lot, but I just realized Venus was definitely one of them. So we have some amazing questions in the chat. If you all have not yet asked your questions for any one of our amazing space scientists, go ahead and do that. We will still continue pulling questions from there. We can go ahead and start. David, one of the questions that we had come from the chat was about the possibility of NASA choosing this Venus project. So you talked about that selection process and how it's one of 4 missions that are currently up. How does NASA make those decisions? I mean, talk about big things at stake. Can you tell us a little bit about what goes into that?
Let me unmute here. It's a really intense process. And I say that as someone who's embedded very much in it right now, like having meetings almost every day about this mission that we're in the process of trying to get through the system. People work for years on these proposals, and they're very elaborate. And a lot of good missions get proposed and don't get selected, because there's limited resources. And, there's a lot of heartbreak involved, honestly, because people work so hard on these proposals and most of them don't fly. But the advantage of that is that by the time a mission gets selected, it's been very, very carefully vetted and, things are well designed, which is good because, a lot of taxpayer money goes into these things and you want them to work. So, but I mean, it's, there's each mission, there's a science team, which is the role that I'm on, where we talk about what are the questions we really want to answer. Then you work very closely with an engineering team, which says, okay, well, an instrument specialist who say, okay, well, here are the actual instruments that we could fly. And here's the total mass that we can launch. And, it's sort of it's like a box that you have to fit everything in. What is the total mass of the instruments you want to send? And then there's other things, other constraints. What is the power that they're all going to take? What is our total power? What's the data rate we want to send back from Venus? And what's the maximum data rate, So it's sort of, you're fitting all these, it's like a multi-dimensional puzzle. And then you basically get your proposal together and you put together a fancy proposal with nice graphics and you try to anticipate all the questions. And then basically NASA assembles these panels, or these review panels of scientists and engineers that go over, these things very carefully, and you wait. And then you, if you get, most missions don't get phase A, which is what we're in now with this Da Vinci, the mission that I'm on, this Venus probe, which then if you get, so there were something, this round, for instance, there were about 20 missions that got proposed. And out of those, there were 4 that got phase A. So most of the teams, were disappointed. And I've been in that role many, many times of being the disappointed team. So I can describe this as like, now I'm like, hurrah, we made phase A, although I'm still really nervous because I've been at this round also, and then you work on it another year. And then of course you can also still get shot down. But so basically when you get to phase A, NASA gives you basically like $1 million and a year to develop the concept a lot more carefully. And so you do more engineering studies and you do, all kinds of engineering tests, and everything has to be proven, that you can only base things on technology that have already been shown to work in space. And, there's a lot of criteria that you have to meet. And then basically there's a site visit, which is very strange now in the time of COVID because the site visit will be virtual. And all our meetings are virtual now. So it's rather odd. You usually do this by sitting around in conference rooms together and then, going out for a beer afterwards together. Now we're all like Zooming like we are. But anyways, so it's a long process. And, the one thing I can say is that, yeah, most of the teams don't get selected, but hopefully you're having a good time working on it. You're working with colleagues pursuing something that you're really psyched about. So it's a good experience, but it's also just, tremendously exciting that to be at this point where the next thing that's going to happen is we get a site visit, and then NASA will say who sometime in the spring, they'll say who got selected. And, objectively, our odds are pretty good now because there are 4 missions in the finals, and NASA says they're going to pick 1 or 2. So they might pick 2 of these missions. And so, I wouldn't say it's like 50-50 because it's not luck. It's like our team is really good and all the other teams are really good. And, you're going all out because you want to be selected. But the last thing I'll say about this is that when a mission gets selected and it's going to be flown, even though you've been competing incredibly hard against, maybe against the people that ultimately win, once a mission is selected, the whole community really gets behind it and is psyched, and cheers the launch and cheers the mission, and the competition gets forgotten because ultimately we're really on the same team. We're on that, like, the Earth team that wants to know about Venus.
I love that, Team Earth. That is a sports team that I would definitely root for.
Go Earth.
Could you, Naomi, would you all like to add anything about that or the process, or no? Awesome.
He's the expert.
Yeah.
So we've got about a little under 5 minutes left. We can go a little bit over that. That's okay. Thank you again, David, for giving us some of your time. So I'm going to direct a question to both of you. It's about the moon. About Earth's moon, I should clarify. I realize that's a clarification I should make in tonight's program. Naomi, some folks are wondering, what were the implications? Did we know about the moon dust before the Apollo missions? Was that a not so great surprise? What were the repercussions of that?
So the lunar dust was something that we really didn't expect the extent of the trouble it caused, basically, right? So I saw in the question, someone mentioned the issue with zippers, right? That dust got stuck in the zippers, and that's a big deal in your spacesuit. So that's one of the first changes they made on the XEMU suit, was got rid of all the zippers, because we knew that was a problem. But they didn't really anticipate how much it would get tracked in and how much of an issue it would cause once it was in there. It was Apollo 17 where those stories of hay fever with Harrison Schmitt really started coming out, and they started realizing this is something that if we're going to continue doing these missions longer and longer duration, we're going to need to address. And with the Apollo program, we were on the surface of the moon for very short periods of time, relatively speaking. The Artemis program and some of the programs proposed by private industry like SpaceX are on a completely different scale. And so this is now learning from experience that we need to figure this all out. Yeah.
Absolutely. And that brings back to another question that we had in the chat about that idea of privatization in space. So Naomi, you talked a little bit about SpaceX's roles on the moon side of things. David, could you tell us a little bit about the role of privatization in exploring our lesser explored galaxy? I don't know what word I'm going to use here. Space things.
Yeah, well, this is really very new. The idea of sending privately funded interplanetary missions. In general, I think of that being something that NASA and the other national space agencies do, and I generally think of the role of these private organizations of doing. Like people said, NASA doesn't need to be a bus service. Like, let's hire private organizations to get stuff into orbit and do those kinds of things. But what's interesting about the idea of privately funded missions to Venus is that there's no profit involved. Like, if you're talking about, most of these orbital or suborbital private companies, even though they're taking big risks and doing these bold things, ultimately they have a plan, like they want to get enough tourists into space or enough cargo so that ultimately, or extract resources. Ultimately, they have some business model where it's going to pay for itself. But somebody like this foundation that's talking about possibly funding us to send a mission to Venus to search for life, they're not trying to recoup and ultimately make a profit. It's more like philanthropy. They want to support work that they think is going to make an important scientific discovery. So it's a really different model. And, you know, I mean, personally, I have mixed feelings about it because I believe in like publicly funded science, you know, but as long as they're going to be people with vast fortunes in the world, then yeah, let's get them to give us some of it to go and discover life on Venus. So, you know, but it's different, it's new, and it's not something that's been done before, you know, the privately funded missions to other planets. So we'll, you know, we'll see.
Absolutely. So we are right about that time. Before we go, I do want to make a pun before I give you all. I'm going to let you all say some final things. But David, I think that the reason that the idea that there could be life in the atmosphere of Venus was shot down is because people thought that you might have had your head in the clouds. With that, I'll let you all say any final thoughts on the 60 minutes of space. We'll start with David, Naomi, and end with Chun before we end our program.
Well, I just want to say thanks for having me on, and I miss all my my Denver peeps, and I hope everyone's staying safe, and let's keep exploring the universe, and we'll get through this, and we'll reach out and we'll find those Venusians, and they'll tell us all the secrets to life that we're still seeking.
And I will throw out there, I saw a great question from Corey who says he's almost 10 and wants to be a spaceman. And I say, keep that up, keep staying curious, keep coming to programs like this, read as much as you can, be inspired by science fiction, looking up in the sky, whatever just gets you excited to learn more. That's how you're going to become a spaceman, and more power to you. Hopefully you're going to be the one we send maybe to the moon or even to Mars. You could be our next big step in space exploration.
Wow, those are hard acts to follow. But I think, you know, with everything that's happened in the world, you know, the museum had to go to online programming. And so, you know, until this year, 60 Minutes in Space has always been a live program at the museum. We've had usually about 100 people in the planetarium or in our Ricketson auditorium, but going online has also shown the benefits of expanding our audience, getting a lot more people to be able to view these programs, and then also experimenting, like bringing in special guests like David. So I hope you know, as we continue this, we'll continue to experiment and have some really interesting programming for you in the future. Thanks, everyone.
Thank you all for joining us. I'm going to go ahead and share my little PowerPoint as I say goodbye to everybody. But we really appreciate your presence and you joining us. As Dr. Yu said, we are so grateful to have a continued audience and continued support for this, and to be able to bring this to you wherever you are, be that in your house, in your, I don't know where else people go. This is my quarantine life. But we're so very grateful for you all. Thank you to all three of our fantastic space scientists who helped us tonight. We will see you all next time.
Thanks, everyone.
Bye, everyone. Good night.
Bye-bye.